So I'd like to invite all of you, and I'm happy to see all of you being here at the very first MySQL Ignite. So the concept behind this is that simply, if a talk sucks, it's over in 5 minutes. Or perhaps another way to look at this is that educate us. Let's just do it very quickly. So tonight we have about 11 speakers who are going to come up on stage and are going to try to impress you with their knowledge or find some way to entertain you for those 5 minutes. Here's the thing. At the end of the show tonight, we will vote, and the 4 top speakers are going to actually get to go and do this again tomorrow morning at the keynotes. So when you're listening to people, take in mind who you enjoy and keep in mind, because at the very end what I'll do is I'll ask you about the talks, and we'll probably do this based on some kind of, hand clapping noise making. So without further ado, I would like to invite Sarah up, and she's going to be our first speaker tonight, and I believe she's going to be talking to us about backups, I believe.
Hi. So my company is Blue Gecko, and we actually have customers that they say things like, backups don't make me money. We get invited in odd situations or in long-running relationships in order to try and help customers have better operational management for their databases. And these, one of the things we frequently talk about is backups with everyone, because everyone knows that backups are super important, and you never ever know if you have them until you've actually tested a restore. We have these great images of tapes, but you don't necessarily know what's on them at any given moment until you've actually pulled them out. So we have lots of opportunities at Blue Gecko in order to test the 2 main types of backups that we do. MySQL dumps, of course, you all know those. And those are a lot like saying, I have all of the instructions to rebuild my database, and here is my data. But they take a lot longer to restore, as we all know, we've all run into. And then you also have the option of cold clones or snapshot clones, depending on your file systems or your logical volume managers, things like that. But the problem with clones is that if you have a problem in your database, be it a logical corruption or a physical corruption, it is replicated in each of those clones. So you sometimes end up with problems that you don't know you have until you go ahead and test and restore them and exercise your database. But I'm preaching here to the converted, of course, because you all do backups, and you all check your restores. So I just want to make sure that you are all, in fact, converted. But here we go through these things, and we still run into problems. And one of the things we're always guarding against is user error, as you might guess. And these may be unintending developers doing things silly, like the Facebook guys said, if I'm about to do something, do I still have a backup in case I do something bad? Or sometimes they're junior sysadmins doing things like running a MySQL dump and then not realizing, in fact, wow, that's an awful slide, not realizing, in fact, that it says use schema there. So even if you actually say MySQL -d schema test and then import the schema, it will still write over your running database. And sometimes these customers don't hit the panic button early enough. They actually say run live data against this newly imported schema. In fact, this is a problem we had about 3 weeks ago, where a junior DBA overwrote a running schema in production and then was not noticed, didn't actually notice for about 4 hours. So there was live data going against this. And what we ended up having to do was import a MySQL dump, replay all the bin logs, and then start parsing out after the time of catastrophe, we'll call it, parsing out using regular expressions what was the MySQL dump inserts and what was actual valid data being updated. And of course, that's with regular expressions. And then, of course, we have to guard against hardware failures. There are lots and lots of ways with disks and RAIDs and all sorts of fun stuff that you can get bad data within a data file. And then you end up with corrupt data, of course. And corrupt data can look like all sorts of things. In images, of course, it can look like pretty pictures, but sometimes you just find that your database crashes and won't come back up. So in those moments, you will again sometimes find that you will have the backups also have this corruption and you just haven't exercised it yet. So you have to go ahead and open them up and try to pull the data back out. Now, of course, all of this is happening under the greatest of time pressures because no customer wants his database down for more than, say, a minute. At any given time. And so you have to be available and open to the possibility that your backups aren't what you hope they are, even though you've tested restores, and you have to be able to change directions rapidly. So we ran into a case where we had cloned backups, and they were lovely and grand, and they opened, and the databases came back up, but there was some corruption actually deep in a data file, and we ended up having to do an export of a terabyte-sized table, and on an import, that turns out that it would take about a month to import, 4 weeks, we estimated. And so we had to do a forklift upgrade to 5.1 in order to get partitioning. We weren't planning to do this during this recovery, but we in fact had to. And so in doing that, we found that doing the forklift upgrade was important because with the B-tree index being larger than the size of the memory available on the server, we ended up hitting that hockey stick curve whereby, like I said, it would take 4 weeks to import. 4 weeks is not some amount of time that somebody wants to be down. So the CTO in my first slide who said backups don't make me money, well, he actually was running Oracle, but he also didn't have backups at all. And he ended up having corruption inside his data files as well. So ultimately, we ended up having to unload the data files by hand, of course. And from there, we were able to reconstruct most of the data. And he immediately started spending lots and lots of money, as you might guess, being able to set up backup projects to handle tapes, and spending lots and lots of money with BlueGecko, which of course I will not argue with, in order to get lots of consultants on site trying to get this data exported out of the raw data files and from there be able to import it back in and piece together what data we had. So ultimately, having backups and knowing that they open doesn't necessarily solve all of your problems, or even exercising all of the data in the tables doesn't solve all your problems, but it gives you a multitude of options and ways that you can make choices in order to make sure you have the data that you need and available to you when you need it and be able to recover from it at that point. So this is my talk on backups and recovery, and I'm hoping that all of you do, in fact, exercise your recoveries and exercise the data in those databases. So, thank you.
So our next speaker here is Robin Schumacher, who worked for years running product management at MySQL. Here's an interesting fact before I let him talk about InfiniDB. Robin is known in MySQL as perhaps being the only person who can actually talk as fast as I can. So when we set this up, I was really kind of curious exactly how much information Robin can actually get done in this time. So without further ado, let's find that out. So here's Robin.
Great. Thanks very much, Brian. Good to be with you tonight. So I'm going to talk to you about our InfiniDB database by Calpont. Now, the first question that we get all the time is, really, who are you guys anyway? I mean, Calpont, what does the name mean? Cal for calculus. Pont is Latin for bridge. This is what happens when you let engineers name a company. But regardless, I wanted T-shirts actually for the show that were printed up that said, bad name, great database. Because that's really how I feel. So we actually named the database InfiniDB instead of Calpont. And people seem to be liking that idea, liking the name of the database. But what is it specifically? Well, first, it's a column-oriented engine. So we are not a row base. We are a column database, column-oriented database. We are great for analytics, data warehousing, read-intensive apps. So if you have read sharding systems that you have, we're going to be really, really good for those. And our unique, I guess, thing we bring to the table is we scale up and out. So for example, scaling up. We will address all the CPUs and processors on your box. If you have one core, that's how fast we'll run it. If you enable all 8 cores, we'll make use of those for both query and load with pretty major reductions in your response times, up to almost 90%, as you can see on that graph there. But we also scale out. We are the only massive parallel processing engine for MySQL right now. So as you add nodes, you shave the times. So if something runs in 500 seconds on one, it's going to run in 200 and some odd seconds on two. Have that on 4, keep going down. Again, another 80 to 90% response time reduction when you scale out. True MPP. We also have what I think to be a really good feature set. Everything you're looking on the screen, except the second to the bottom, our MPP is in our Community Edition. We save that for our Commercial Edition because I have 2 kids right now, 10 and 13. I got to get them through college somehow. Got to have some reason for people to pay us. But the claim to fame is, again, fast load, fast query. And of course, that begs the question. Well, sounds good, but really, how fast are we talking about here? How fast can you really run versus row-based databases? Well, I took a guy who's one of the best data warehousing gurus out there externally, and I said, please, test us against the database you are the best at, and let me know how we do. This is what he did. Leading row database, can't name it, it's not MySQL, but it's another database we know really well. 22% less space we took up because of our compression, 22% faster in terms of load times, over 60% faster in total response times, and on average, 60% faster. And also, notice the more predictability down at the very bottom. Percona has also been very good with us in terms of helping us out, doing various benchmarks, giving us great feedback, which we're really grateful for. Here's one of their latest tests that they did. Less is best. And as you can see, we did pretty well against the other column-oriented databases that are out there. So we're really pleased with that, and we thank them for their tests there. Also, you might ask, well, when I add data, do I get the same thing? So that's nice for a certain data volume, but what if I really pump up the volume? Yes, indeed. Same thing in terms of predictability, what's going to happen? 6 billion, 60 billion? Yeah, it's going to take a little bit more time, but you're not going to see huge spikes like you might see with some other databases. So we are very predictable with how we run data. Now, questions that you might have that are still remaining. What else do I need to know about InfiniDB? How can I work with it? How can I get it? All of those type of things. Can it work with other storage engines? Let me talk a little bit about that right now. So the first question we get all the time is in terms of connectors. Do I have to have some sort of a special connector to work with you guys? No, you don't. JDBC, ODBC, anything that's out on the MySQL website, you can use your favorite BI tools, your favorite dev tools that you use, any of the admin tools you use, we will work fine with them. If you can connect to MySQL with what you're doing today, you can connect to us and work with us in the exact same way. Can I use other engines? Absolutely. So Larry Ellison said with Oracle Exadata, we're the only ones that can do transactional processing and data warehousing in the same box. Untrue. We MySQL users can do the same thing. You can have InnoDB, InfiniDB running on the same database in the same instance, works like a champ. So you can do that on a single box if you like, and if you want to scale out with us and do that, you can do that as well. So you can have InnoDB running on a single box and then scale out using our modular architecture to be able to scale your loads, attack larger data volumes, things along those lines. Either scale up or out, works like a champ. No problem there. So what other things do you need to know about us? First off, our 1.0 is out in February. Open source edition cranked out last October. We have a release early, release often. Maintenance updates, community gets the bug fixes and everything first. So we hold nothing back there. And basically, we're going to go where the community and the customers send us. So we have forums, everything you can post on. Tell us what you think. Tell us what you'd like to see in our next releases. And speaking of that, what is exactly coming next? So as I said, we launched our 1.0 in February. That's out and available now on our .com and our .org site. So it's calpont.com, infinidb.org. And in terms of what we're looking at down the pike here, the next release is going to come in July, and that's going to be our 1.1. The thing that you're going to like about 1.1, high-speed subqueries. I've seen these already in action. We're flattening them into joins. We're seeing things that take my ISIM literally days, seconds with the high-speed subqueries. We can do subqueries today, but we just toss it over the transom to MySQL. High speed's coming. 2010, 1.5.2.0, we're going to have a full shared nothing support. Where we're going to be basically an open source Vertica. And then next year, we'll see what comes down the pike. Now, in terms of how can I get it? How can I actually use you guys? Our infinidb.org site contains our community edition. You can go out there, download it for free, works on a single standalone server, works like a champ. The benchmarks that you saw that were run against the leading row database was our community edition. So you can go out to infinidb.org, grab that. If you want to trial the MPP version, that's calpont.com. All of our documentation, articles, white papers, everything else is for free, out there and available on both .com and .org, so we're not going to charge you for any of that. And with that, I believe I'm done. Thanks very much.
Thank you, Robin. And as anyone noticed, he started off very slow, but it picked up with the pace. Next up, we have Jerry. He's going to be talking to us about monitoring, and we'll see what he has to say about that.
Okay, see how it goes. Basically, my talk tomorrow will be about beyond monitoring. Monitoring software will give you a number of results, but then what do you do with those results? How to interpret them? So what I'm going to do in order to make you think outside the box is actually confuse you a little bit by taking a few concepts that come from other disciplines, especially mathematics and communications and quantum physics. And hopefully you'll figure out what does this mean in terms of diagnosing your database. I learned this actually from being a parent. I have 5 kids. And basically, as I confuse them, I make them think, and they learn. The numbers, I think they have different speeds, but the names are first Newton, different equations. When it comes to show status like connections is, do you need to know the value or how it changes? Nyquist sampling theorem, and this is the problem I'm having right now, basically you have to sample. At what rate do you sample? And the theorem that says that you have to sample twice the number of the event. Here you can see an example where you experience aliasing. And if you do the sampling right, those peaks at the end basically mean now I'm sampling at the rate that it's happening. Heisenberg's principle basically is when you measure something, you might actually be affecting what you're measuring. And for example, your tests are increasing the number of connections. So what do you do now when MySQL doesn't help? For example, you have a lot of aborted connections. And from now on, I'm going to talk only about Linux tools, since I'm not an OS X user, use Google. Well, you use other resources like SAR, Netstat, IOStat, TCP dump, Wireshark, and lots of that. I'm not going to explain anything of that here. Man is your man, and so is Google your friend. Basically, you need to understand what is the underlying application and the database usage you're looking at, so you can do and design your sample in what, that's Newton, when, that is Nyquist, and how, that is Heisenberg. So, and those are basically the concepts: rate of change, sample rate, and uncertainty. Test, interpret, learn, and repeat until satisfied.
Good. And sometimes we have to educate a little faster than others. Could also be just because he turned in 21 slides instead of 20 slides, so you never know. So next up, we have Todd, who will be doing painting data with entrance and MySQL. So I take it over to Todd.
So my name is Todd Landis, and this is data painting with entrance in MySQL. And there's an example up on the slides now that shows one of the images that we'll be showing later on in the talk. My time is a little different. So entrance is a desktop application. We embed SQL queries in, or rather plot setup information in SQL queries. This is an example of a table view in our window. And we make a lot of charts. So if you take a look at the slides now, you'll see some of the examples of the charts that we make. Each of these is made by one of those scripts I mentioned at the beginning there. So you can import data using the entrance import dialog, or we can meet data in MySQL. So the idea is that you have a batch file of some kind importing data. You write scripts, put them in entrance, go out and image the data. So this is our twist. You see the highlighted plot part of that command is our chart setup information, and below it you can see a select statement that can be any MySQL select statement. And the result of that script produces a chart that looks like this. So in about 2 minutes you can install entrance. In about 30 seconds more you can make a chart like that. So the one thing to remember if you're going to play with this is that axis labels, red line, those are chart series, and they have to match up one-to-one with columns in the table or the result set generated by your select. So the main part of this talk, though, is data painting, and there's an example on the screen now. You can see a scatter plot with a bunch of blue points, and some of them are red. And on the next slide, we'll see how to do that. So these are just MySQL statements. You're familiar with update, of course. And they're setting strings in a color column to color names. The first one is using blue, and the second one is putting in RGB values, of course, for red. You set up a color override in the plot part of the entrance command, and you match that up with a color column in the MySQL select statement. And that's the result. So you can imagine scatter plots, bar charts, line charts with segments that you want to emphasize. And we call that data painting. So here's an example using a calculated column. Again, you see the color override in the plot part. And in the select part, you see a cascade of ifs. And this is a way of getting a color spectrum, a simple way of getting a color spectrum corresponding to a range of values. There's the result. I actually could give the other guy some of my time. Okay, so here's a more exotic example. Down at the bottom, you see from zip codes. This is zip code data with latitude, longitude, and associated values. One of them is states. And so if we look at the result of that script, we see red zip codes as the default with California blue. You could do the same thing with marketing data, make a marketing heat map corresponding to sales and so on. Finally, I'd like to talk about interactive painting. This is only in the desktop version. If you take some steps to set up the script correctly, and I've written a note about how to do this, you can dynamically choose points by dragging out a rectangle on the screen. In this case, they're painted green. The cool thing about this is that the green color is written back into the underlying database table, which means that other applications or entrants can spot it. You can actually see those colors from other scripts running SQL. So on the next slide, there's an example that shows that the green color is visible to the MySQL client, and we're actually calculating averages. The right side there are counts for the different colors, and at the bottom, a matchbox selection of the green color in entrance itself. And that's all the time I have. There are the charts that we make, and dbentrance.com is the place to go for more information. All through.
Thank you very much. So next up, we have Baron, who is going to be telling us the differences between ExtraDB and others. So thank you very much.
Thank you, Brian. So I'm from Percona. We created Percona ExtraDB and Percona Server with ExtraDB. We do a pretty bad job, I think, at the current moment of telling people what the differences between ExtraDB and the other engines are. In fact, somebody posted on our blog just today and said, do you have a fact sheet? What's the differences? Well, we don't, so I thought maybe I would just do a little quick talk here and sort of go through some bullet points. Before I start, I just want to say that we don't... independence and objectivity is a core business value of Percona, so nothing that we say or write is paid for, and we try to recommend what makes sense for our customers, in our opinion, as consultants and experts. So I just wanted to keep that context in mind as I go through this. So Percona Server with ExtraDB is actually an enhanced version of MySQL Server. It's based on MySQL 5.0 and MySQL 5.1, and Percona ExtraDB is a storage engine which is derived from the InfiniDB plugin. We also have Percona Extra Backup for non-blocking hot online backups. Percona Server, I already said that it's derived from MySQL. It's 100% open source and GPL licensed. It's similar to MariaDB in the sense that we're kind of peers with MariaDB. We share patches back and forth with MariaDB. MariaDB includes the Percona ExtraDB storage engine, for example. And our Delta, just to give a sense of where we are in relationship to our Delta, is a provider of community builds, which is kind of downstream of both MariaDB and Percona server. They consume our patches and make community builds of them. So what are some of the enhancements in Percona server that make it, and Percona ExtraDB, that make it different from the versions that you can download from dev.mysql.com? So in Percona server, the main enhancements are the so-called slow query log enhancements. These are the oldest enhancements that we've made. Makes the slow query log not a slow query log, it makes it an all queries log. The next category is user statistics, which we ported over from Google's user stats v2. It shows you information about how objects are exercised inside the database, missing information about users, tables, and indexes so that you know how your queries are using those objects inside the database. So you can find out things such as, are all of my indexes used? ExtraDB is the storage engine derived from InnoDB plugin, which is built into Percona server with ExtraDB. It's a storage engine, not a database. That's what Percona server is. And many of the changes are backported into the 5.0 series as well to help people who don't want to necessarily upgrade to 5.1. It has faster I/O. You can add more read-write threads to it than the standard built-in InnoDB in 5.1. It has smoother flushing and checkpointing. In the graph on the top, the red line is the ExtraDB. The red line is the InnoDB plugin doing sort of that Philadelphia Turnpike kind of a thing. The line on the top is ExtraDB doing a nice smooth checkpointing and flushing. We split up the global buffer pool mutex into a variety of other mutexes to reduce global points of contention. And I invite everybody to go to that tiny URL and reproduce our benchmark results. We look forward to doing that with the new release of 5.5. There's fast recovery, which also, of course, a couple of days ago was announced in 5.5 as well. Looking forward to checking out the source code to that and seeing how 5.5's version of InnoDB gained faster recovery as well. I would assume that there's been some interplay between us and Oracle on that, as there has been in the past. There's also fast warm-up, so you can record to disk before you shut down the IDs of all the pages that were in your buffer pool, and then when you start the server back up, you can tell it to reload those things right off of the disk, and it does that very fast, and so your server is warm in minutes instead of hours or days. This is a 26 gig buffer pool. You can easily see days of warm-up. There's multiple rollback segments because we found that the rollback segment was actually an extremely hot point of contention in certain workloads. So intensive insert and delete workloads were really falling off in scalability. So we exercised something that was sort of lying dormant inside of InnoDB and enabled multiple rollback segments. A serious pain point for folks who have had tens of thousands or hundreds of thousands of tables was the fact that InnoDB would just eat memory until it was all gone. And so there would be many gigabytes of memory unaccounted for. We've solved that by letting you configure how much memory you want the data dictionary to use. So this is great for SaaS apps or hosting providers. You also have control over the insert buffer. By default, the InnoDB insert buffer is it's not configurable. You can only tell it you can't tell it how much of the buffer pool to use, and it goes up to half. It also doesn't start to flush the insert records out of it until it reaches that limit. We changed that in Percona ExtraDB. Well publicized by Don McCaskill was the changes we made to enable higher concurrency and a greater number of concurrent transactions at once. He was running into the 1,024 transaction limit and blogged about that at that tiny URL. We solved that for him, last year, or year and a half or so ago. That was a nice change. You can also import and export tables, something that you can't do with the standard InnoDB. You cannot simply copy a file, even if you have InnoDB file per table, and then bring it into another server. Well, with Percona server and extra backup, you can, and you can do it fully online, non-blocking, with no downtime required. You can simply move tables out of one instance and move them into another. ExtraDB stores the slave position in the transaction logs so that after a crash on a slave, it'll actually overwrite those relay log.info files, and when the recovery is finished, It'll pick up again in replication at the correct point instead of replaying or having a gap in transactions. So this makes your slaves crash-proof. Also, there's a really serious pain point in standard InnoDB. If there's some corruption in your data, InnoDB says, I assert and I crash the whole server. That's not a good thing to do. Bringing down big database servers for a single bit of corruption is not good. So we fixed that in ExtraDB. It reports corrupt just the same way that MySQL currently does and then keeps on working. We added a bunch more diagnostics. There's more information schema tables so that you can find out what's in your buffer pool. Very interesting question to ask. You can inspect the data dictionary, which has always been stored as tables inside of InnoDB, but you didn't have access to them. And you can optionally enable I/O statistics per page so that you can find out what your I/O is doing. Thank you.
Thank you very much. Next up, Bradley is going to be talking to us about what is a performance model for SSDs.
So I'm Bradley Kuzmal. I'm at Tokutech and MIT, and I like to measure things and get fast performance. And so if I'm trying to understand how to use SSDs so I can define data structures, and I see these funny graphs and I can't figure out what's going on, so I wanted to do that. And this, I'll get to this one in a second. So basically, this was the beginning of the Odyssey, is this benchmark that Percona ran, running IIBench. The top curve is TokuDB, those two curves, and one of them is the SSD, and one of them is rotating disk. And the bottom one is InnoDB. Again, one of them is SSD, and one of them is rotating disk. And the SSD is a little faster, up is good. But, you know, how come we're faster on rotating disk than InnoDB is on SSD, and why isn't InnoDB getting good performance? It's still a little bit of a puzzle. I can't, what? I'll talk into the mic. Okay, so I got an Intel X25E, and I tried to look at the spec sheet to figure out what was going on. And according to that thing, it can read 250 megabytes per second with 35,000 IOs per second with random 4 kilobyte reads, and it can write 170 megabytes per second, and about 3.3 writes per second. So MySQL was too complicated, so I said, well, the next experiment to simplify things is to measure Berkeley DB, and I saw this sort of performance, which is sort of the hockey curve, except that there were two steps on it. The first one where Berkeley DB fell out of cache, and the second where it fell out of main memory. So then I said, well, that's too complicated. Let's do file I/O. So I built a 12 gigabyte file on a machine that had 3 gigs of RAM and performed random reads and writes, and then tried to make a performance model for that system. And the performance model is a fairly simple model where you try to assume that there is a startup cost for doing a read or a write, which is the seek time, and then there's some bandwidth that you get once you've started going. So the simple model for the time for a read is it's the startup cost plus however your block size is divided by the bandwidth, and similarly for the writes. So I measured for varying block sizes, going from very small to something like 4 megabytes, and the bandwidth I got sort of started out very low and got up to 120 megabytes per second on reads, and this was on a machine that was supposed to get 250 megabytes per second, so I wasn't getting that. So I said, well, what would this curve look like if this model was what was predicted by the data sheet? That is, the 16 microsecond startup time plus 250 megabytes per second. And this is what the curve ought to look like, but this is what the curve really did look like. So that's a little disappointing that I couldn't get on this thing to go faster. So I said, well, I kind of did a curve fit to try to find an actual model. The actual startup time looks more like 500 microseconds or half a millisecond, and about 120 megabytes per second once you're going. It's nothing like 35,000 IOs per second. I was getting sort of 4,000 IOs per second. Write performance kind of had a similar story. I think it was a little less crazy. The write performance also had about a 500 microsecond startup time, and I got 80 megabytes per second. And the spec sheet said I should sort of expect 300 microsecond startup time and 170 megabytes per second. As I vary the block size when I do writes, there's sort of an interesting thing that happens that that you get, what is this? You get about 60% of what the spec sheet predicts when you are writing. I don't even remember what this curve is. Well, it's not as good, whatever it's supposed to be. But I'm fried. So, well, I did manage to get more reads per second by doing multi-threading. So by getting a whole bunch of threads trying to read random blocks at the same time, I was able to get up from 4,000 reads per second up to 11,000, and that's still short of the 35,000 that the spec sheet predicted, but that's one way to get some performance. So what's going wrong? Well, maybe my drive's getting old because I've actually been using it, but it behaved about the same when it was younger. I tried writing to multiple files. Mark Callahan suggested that would help, and it didn't. I haven't tried XFS, which might help, and I haven't tried sort of going around the file system, and maybe that would help. When I'm designing data structures, the question that I'm trying to get at is how big should the block size be? If you use a really big block size for B trees, then you sort of end up making range queries fast, but point queries get slow. And if you use really small blocks, then point queries are fast, but range queries are slow. And so the challenge is to find a good halfway point. And the halfway point is when the seek time equals the transfer time for your block size. That sort of guarantees that you're always within a factor of 2, no matter whether you're doing range queries or point queries or some other kind of a mix. So the half power point for this SSD, according to this data, suggests that your blocks, if you're doing reads, unthreaded, you need to do 60 kilobyte blocks, and if you're doing threaded reads, you get more reads per second, so that's 30 kilobytes, and writes should be 40 kilobytes. You compare that to a disk, the half power point is between half a megabyte and a megabyte. So one approach that we use at Tokatech is try to avoid this whole thing by having data structures that don't depend on what the actual block size is. There's data structures that turn out to be asymptotically optimal without knowing the block size, and those are called cache-oblivious data structures because they're oblivious to the cache parameters like the block size of your system. So we put that stuff into a storage engine. It gives these good performance so that we're actually faster on rotating disk than InnoDB is on SSD, and that's what we're selling.
Thank you very much. Next up, we have Jillian, who's going to be doing the Guns N' Rules of database management. So here we go.
So a few months ago, I started compiling a list of rules that I'd come up with over the years on how to be a DBA. But I soon gave up out of frustration because it was more a list of how not to be a bad DBA by not doing what I did rather than on how to be a good DBA. But I think now there's actually a place for that sort of set of rules because databases are inherently very dangerous in terms of what you can break, and a new DBA could learn from the mistakes of others such as myself. And the first rule I broke was don't test on production. Now, you know this rule, and I know this rule, but your supervisor who walks up to you one day and says, oh, just run that on the live databases, well, doesn't know this rule, and so you have to show them by deleting the contents of a very large table. So yes, one of the first things I did when I became a DBA was set up a test environment for this table. But it's been something that over the years in various companies I have had to fight for. I don't know what's next. This is going slowly. I don't know what the next slide is, actually. Oh, yes, okay. So databases are sort of like heavy machinery, and they should not be operated by people who are under heavy sedation or who are drunk or sick. And I had followed this rule quite easily for the last 5 years, up until 2 months ago when I found myself in extreme burnout from a large project and accidentally dropped a table. And yes, at that point I realized I had to just cut myself off from the databases, except that I couldn't just go home from work. And so my solution for that, and I think other people have a term for this, is the perpetual boss key. And the idea is that you set up your computer monitor so that it looks like you're working. I set up a whole bunch of terminal windows. One will be connected to a MySQL test database. Another will be tailing a log so that, you know, the screen keeps changing. I've gotten away with this quite well so long as I, you know, keep my head upright and I'm not snoring. I've heard other people as well have a different name for this, and I talked to the sysadmins at work, and they do this as well. So I thought it was my idea, but obviously it's not. And I'm yet still ahead of myself. I like to monitor everything I can, and if there's a way to redundantly monitor something, I like to do that because a problem may manifest an error log before it affects performance, and you want to make it look like your databases are always running smoothly. At the same time, though, as a DBA, you need to make sure that it doesn't look like you're not doing anything, because you know, management trying to cut some cash will sort of think, well, the databases are running great, we don't need a DBA anymore. Or they, you know, at best they will say, well, why haven't you worked on these other projects yet? So in that case, you need to document to them what you're doing, but also document to yourself the steps you've taken to fix problems. Because as a DBA, I've been woken up quite a few times at 3 in the morning. And me at 3 in the morning, I don't know what day it is, and I don't even know what I do, and I really appreciate having a list of instructions. And even, you know, you can try to do all the best practices, but eventually you will screw up something. And I work with a bunch of sysadmins, and I cannot hide that from them, so I just have to fess up. You know, they will mock me for a week, but it's better that than them mocking me behind my back. Oh yes, and I have a very important rule about taking breaks. Well, I can't judge that. Yeah, there's a lot of really boring and slow and tedious work in DBA work. So if you can script anything that you don't like, then do it. You know, then you can spend more time watching YouTube or, you know, working on something more interesting. Don't be clever. What I mean is if you're given a problem to solve, do not try to impress people with coming up with the most convoluted and confusing and strange and buzzword-filled you know, solution to something, because you are going to have to maintain whatever monster you created. So, you know, the fewer points of failure, the better it's probably going to be for you, and it'll probably work better that way, you know, in the system as well. Help developers. It's always on the job description that you should help developers with their SQL queries, but it's easy to forget about that because you're too busy trying to save the databases from them. But you know, it's the low-hanging fruit of DBAs to do SQL queries. It's hard for developers. It's easier for you. So you know, they really appreciate it, and then sometimes you get gifts. I made a joke once that I required chocolate for helping a developer with one query. And 2 hours later, there was like a nice, you know, bag of gourmet chocolate on my desk. It doesn't have to be chocolate. I've also received beer, you know, whatever you like. But, you know, you need to sometimes nudge the developers into appreciating you. So I find that, you know, it doesn't hurt to ask. Yeah, that was the first gift I got. It was really good. So yeah, that's my whole talk. I want to actually write an article about this, so if anyone has any suggestions, stuff they could add, you know, I'd love to hear it. Thank you.
Hey, thank you very much. So next up, we have Monty. Monty will be doing the full Monty, and hopefully we'll still be able to, you know, put this up on the internet later on. So here, without any to do, here's Monty.
Thanks. So, quick version of the keynote. Monty Program, AB, founded in February 2009. We are now 20 employees. We are corporate sponsor and driver of the MariaDB project. So, but we are only driver. We help others to be part of us. I was saying that why are we doing this? We are saving the people, save the project. I want to ensure that MySQL will continue to flourish open source, whatever happens. I want to provide a good home for the developers. And we have been quite successful in doing that. So we adore to the hacking business model. You should actually go to our site and look at this. If you are about to start a company where you have lots of people, peers, and you want to do something together, that's a perfect model to work. It's employee-owned, developer-driven. We are doing a company where developers would love to stay. We have hired also all the sexiest developers in the MySQL ecosystem. Please stand up. Wait. Hey, Sanya, show up. Yeah. Well, that's not right. We are missing some. Even if Bruce's parents seem to believe otherwise, we haven't able to hire everyone. And we work by doing development on MariaDB and MySQL. We do third-level support. In other words, we fix bugs. We have other support partners in front of us. We do custom development, and we spend 40% of our time to develop the MySQL server or MariaDB for customers. And we hope to be profitable this year. And our support offering seems to show that we have a good chance of doing that. Drop-in replacement for MySQL. So if you have a problem with MySQL or with Oracle, just put in MariaDB, your problems is all solved. We are community developed, and if actually you want to hack on MySQL, welcome, join our IRC channel. We are happy to help. And we are also very active by looking at everything that happens in the MySQL community, all patches that flows in, and we are incorporating those extremely fast. So we are MySQL, we are enhanced, we are actively pulling in all patches, so we always be before MySQL. More features, we are doing releases, basically one release a month. You can get daily snapshots if you want. We already started to have a track record for doing this. Of course, MariaDB 5.1 is based on MySQL 5.1. And we have added most of the open source storage engine already in 5.1. There exists some other ones like Spider, Sphinx, that we are going to add to 5.2. We are working with the developers to ensure that that's happening. And we also have the things that Baron was talking about, slow query log, extended statistics, micro precision. Those we got from Percona. We're happy for that. We are working with them. We have a table elimination. I talked about that in my earlier talks. With helps you with complex views so you can ignore tables. And we also are active in the community. As we have some extra time cycles, all developers. This Croatian sorting order, somebody's asked on IRC that, can we do this? The whole Croatia depends on, when it comes to choice database, to use MySQL or not, if we can get the sorting solved. We solved it in a couple of days, and they were happy. So, as you can see, this slide was sent some weeks ago. We didn't have a beta. We did release in time. That's good. And the 5.3 branch is open. That means that we are now developing features for the next one, where we have a lot of nice optimizations that should give you great performance. So in 5.2, basically this should be stable. The only reason it's not called stable because it's not proven yet. All those patches has been extensively tested by community and us. So we expect 5.2 to be stable basically within 3 months. Of course, code is on a launchpad. All the Maria forks and branches seems to be there. You have all the paths here where you can get those. And we also work with other people who have their trees there. So these are the different main lists we have, and of course a launchpad. And We don't have any internal IRC channel. Everything we do is on the Maria IRC channel on Freenode. And we get lots of people coming there, discussing there. I'm there as long as I'm awake. You can find me there, most of the developers. So it's very easy to communicate with us. The MariaDB Unlimited support subscription, it's really unlimited in most senses. And it's a best possible offering you can probably get on MySQL or MariaDB support. Thanks for coming. We will have a buff later. We have black vodka. And of course, if you think I'm boring, Mark Callaghan will probably be there too because he likes the vodka. So you can meet him there too. Thanks.
Thank you very much. Also, thank you for the picture that I'm sure will live on long beyond this conference. Next up, we have Shiri. She'll be talking about MySQL Tuner.
Alrighty, MySQL Tuner 1.0 was developed by Major Hayden to be a quick sanity check of databases. It checks memory usage if you're on a 64-bit architecture, table size, status, and system variables. It does calculations like %of temp disk tables, and then it makes recommendations, not all of which were relevant. Another problem was that it hard-coded everything, what to check, the threshold, and the recommendation. I started modifying MySQL Tuner to be completely offline using files, and then I realized that what I really wanted was something where I could easily change what's checked, the thresholds, and what the recommendation said. MySQL Tuner 2.0 is written in Perl. It works by storing information into a key value hash. Then it parses a config file, which has the calculations, the thresholds, and the output. Right now, the keys are the variable names from show global variables and show global status, but the keys can be anything, limited only by what you can code in Perl and by what I can code in Perl. You can get key value pairs from files for a completely offline mode. In the future, MySQL Tuner can be coded to get information both from files and the database. I haven't changed how MySQL Tuner logs into MySQL, so it should in fact work on all platforms that MySQL Tuner 1.0 works on. In the config file, comment starts with a hash, and each line is broken into 4 fields. The part in red is the expression, the blue part is the comparison operator and value. There's also the label and the output if the comparison matches, and the -- recommend option is used. The label and the value of the expression are always printed out. MySQL Tuner compares each word in the expression to the keys in the key value hash and replaces matching keys with their values. This is the line in the actual config file for % of slow queries. We can write readable expressions, and Perl matching does the hard work. So be careful about what keys you put into the hash, and be careful not to overwrite existing keys. In the next example we'll see on the next slide, MySQL Tuner will show the output too many slow queries if the % of slow queries is greater than 5 and the recommend option is set. The comparison and expressions are Perl expressions, so you can use any function and operator you want, like the substring function, and we should be on the next slide because you went back 2. That's okay. See? Substring right there. It's all good. You thought I wasn't even watching that, didn't you? MySQL Tuner 2.0 has kept the functions written in the first version. We can go to the next slide. Pretty uptime is self-explanatory. HR means human readable. HR num makes a large number readable, and HR bytes shows a value in gigabytes, megabytes, etc. I added a function called HR by time, which takes a value per second and makes it readable. If it's less than 1, it's converted to a value per minute, per hour, per day, whatever. 0.078 slow queries per second is hard to understand, but 4.69 slow queries per minute makes much more sense. Here's an example of rate of sorting causing temporary tables. We divide sort merge passes by uptime since flush status to get the per second value, and then we pass that to HR by time. If either second or minute appears in the result, the recommendation will be increase some system variables. What if you want to see the values of system variables themselves? Here's an example. Pass sort buffer size to the HR bytes function. The nature of MySQL Tuner is to check against a threshold, so I gave it a bogus check, and then a bogus result if the check doesn't work. By default, the output prints in pretty format. We're going to see a line in about a second about what the output looks like. There you go, in CSV format. The -- output command makes it easy to plug in a new output method. In the future, I plan to code it so that the output can go into a database table. Again, the limit's what can be coded into Perl. We're going to see some sample output of MySQL Tuner 1.0.1, the older version. Note that it's nicely formatted. There's a bunch of groups. The formula for determining fragmentation, by the way, is not actually accurate, so it's not in MySQL Tuner 2.0. That's the storage engine statistics group. We see lots of percentage checks, but those aren't always helpful. We're going to see in about a second some MySQL Tuner 2.0 output. There you go. The command used at the top is very simple. It states what config file to use, the username and password for the database, and yes, print out recommendations at the end. The sort rows entry in the right-hand column shows a value created by the HR by time function. It's going to appear in bold in about a second. This is lots of information. It's certainly easy enough to remove some of the checks from the config file or add new ones in. The bottom, which is going to be on the next slide, has the recommendations. They're actually worded more carefully than the original MySQL tuner. I'm sorry if you can't really read that. And I hope they're actually more helpful. Of course, you can always edit what the recommendation says. Like all software, MySQL Tuner 2.0 is not perfect. Ideally, the output could have groups like the first version. It's possible, it just hasn't been coded yet. You can only check one expression at a time, but the expression and comparison are all Perl, so you can do complex tests like check if the result matches anything in a list. There isn't really a lot of logic flow, so it's hard to have tests like, hey, if the query cache is off, don't check the size and efficiency. I think having groups would make that much more easy to implement. And it's not a DBA in a box. You still need to know what the numbers mean. This just saves you some math. The README file shows you not only the options, but typical use cases, which are shown in italics. The flags themselves are shown in bold. The -- help option is a good way to see the available flags as well. The name MySQL Tuner is used with permission from Major Hayden. Also, he seems to no longer be working on MySQL Tuner due to lack of time, so I guess I'm maintaining it now. Here's how to get it. MySQL Tuner 2.0 is available on Launchpad, and I encourage people to give feedback, submit bug reports, and of course, submit code patches. Thanks very much.
Now as we pause for a second as she cleans up her cards, though, tripping hazards alone might make this even far more interesting. So next up, we have Mark Callahan, who is going to be talking to us about a future.
So Shiri, with the key value pairs, the NoSQL crowd you're joining. Trader, but that's okay. So I'm here for MySQL for high scale. So by high scale, I mean websites who are doing a lot of traffic or who hope to do a lot of traffic and are architecting for the future. I talk a lot, but I try not to pontificate. I try to give a lot of data for what I say. Right now, I'm pontificating, so sorry about this. Change is coming, and I say this from my perspective of where I work now and where I may have worked in the past. MySQL has been the default high-scale solution, and it won't be the default solution in the future, which is arriving soon. A few years after that, once more things get deployed, it won't have the majority of high-scale deployments. So at that point in time, we will have less market share. Is this important? Does it matter? I don't know if MySQL ever made much in money from high-scale customers, but I think the product and side effects have been very valuable. For example, conferences like this, which have a lot of participation from high-scale customers. So I think it is important for MySQL to remain relevant for some of us who want to continue working on MySQL. So why do we need to change? Some people are changing for very good reasons. The solutions that they're switching to do less, but they do it better. Provide automated failover, just less cost to operate. Other reasons, SQL is hard to use and it's hard to optimize for high-scale customers. And eventually some of the migrations from MySQL to NoSQL will learn that whatever they're migrating to is also difficult to use. So one of the responses we've had in the past few years is forks. And by forks, I mean things that are very similar to MySQL and things like Drizzle that are fairly different from MySQL. I'm not trying to provide an answer here, but the questions I have about these forks are we innovating from them, and are we losing efficiency by doing this? Fragmentation, I don't think official MySQL and derivatives, excluding Drizzle, are growing the community. I don't think people will volunteer to work on these projects in the future. They will have to be hired. If I were a developer starting out, I would choose to work on a NoSQL solution at this point in time because I would have a bigger impact. I could do a small feature in MySQL, or I could help get Cassandra and HBase much more likely to be usable in production. As someone who observes the mailing list, There's not much activity on it, the official mailing list. MariaDB has a lot of activity. It's mostly commits. Drizzle, again, I'm excluding. Drizzle is very active. And the thing we do discuss on the mailing list right now is mostly coding standards. If I were thinking of hacking on something, MySQL is open source, but development is not. Once a year, we get surprises about the features. This year, the surprise was great. The features that have been described in 5.5 are excellent, but if you're trying to be a developer working on this, it's a big step function. Once a year, you'll learn what's new, and then what the new bugs are and what to work on, and then a year later, the work that you did to fix them may or may not have been relevant. Who wants to hack on MySQL? InnoDB is fun to work on, and I lost my slide. So what do? We share the data center. This stuff, Cassandra, HBase, is coming in. We have to work with them, interoperate with them, replicate to them, share data with them. Okay, so another thing to do is provide alternate interfaces to MySQLD. I do a lot of queries that are the same again and again and again. I don't want to pay the price of optimization, and I think I know I can get faster into the server without using the client-server API. So I need an alternate way in. MySQL proxy is another way to innovate and share access, but we need MySQL proxy that's generally available with high performance. And if you go to the website now, it's an alpha release, and there have not been many releases, at least official releases. The big thing we can do is what 5.5 is doing. We can make MySQL amazing for OLTP. It's far, far ahead for what you can get for performance on a single node compared to the competition. And I think we should stress that. For commodity, 16 core servers are here now. If you're buying a Nehalem server, you're getting 16 cores. We'll have more cores next year. We can get PCI-based flash devices that do 100,000 IOPS. We need software that can do 100,000 IOPS, or we are wasting money on that hardware. And the other thing is, let's provide an alternative to InnoDB. Let's make them compete. PBXT, ExtraDB. What if Maria turns back into an active storage engine? It's another option for users. And making InnoDB and MySQL remain competitive is good for users. The other things, there's more features I want for high scale to make my life with respect to managing a web service or a data service easier. Stored procedures, online operations. I can't take a database down to do a schema change or to do resharding. That's it. But a lot of work to do.
Thank you very much. So next up is actually me, though. Yeah, you had to put it on the right slide. So, nope, wrong slide, fail. Yep, go all the way back. Oh my God, they're seeing the good stuff. Okay, so what I'm here to talk about today is I'd like to give you a guide to NoSQL. So I'm sure you've been hearing all about SQL and NoSQL all week, and you probably are wondering, well, what is NoSQL? Well, NoSQL is a non-relational data store that does not need a fixed schema, and that usually avoids join operations. At least this is what Wikipedia has said it is so far. SQL obviously is the language we've all been using, relational, algebra, all that, all that fun stuff. So what does all this actually mean in the end? So what we get into next is the slide didn't update. No, not on screen. Oh, well. Okay, now we're at things. Okay, so what do we really get into? In our world, for instance, we have select group by. Now, what does this mean? We take some data, and we take all this data, and we come up with some aggregate value based on this data. So we look at sums, we look at averages, and in the world of the NoSQL world, which the slide jumped on me again. So we'll assume we're on the next slide. At this point, what is the MapReduce world? No. Okay, now I can see through the backside. This is much better on YouTube, by the way. Okay, so MapReduce. In the NoSQL world, what they have is MapReduce. And what MapReduce is you take some values and you take some data, and you take a bunch of machines and you throw it at a bunch of machines. So instead of having a single machine with, say, indexes or anything, what you do is you buy a bunch of computers, push everything out. Now that's what it is. That's what a MapReduce is. So basically take some data, push it out to a bunch of machines, have them calculate it, summation it, hand it back to you. In our world, of course, we have join operations. What are join operations? Join operations, we take a set of data, we find a table. Now, what do they have in the NoSQL world? We have multiple MapReduce, because in their world, they don't have joins. So what do? They take a lot of data, they throw it out to machines, use MapReduce across a lot of machines, multiple MapReduce. Yes, this is going poorly. Yeah. Anyway, table scans. So in the SQL world, what do we have? We have something called table scans. You know, we look at a bunch of data. We want to scan an entire table. We want to find out what that data set is. So in our world, in the SQL world, we have something called a table scan. In the NoSQL world, what do they have? They have multiple machine MapReduce. So instead of scanning a single machine, what they do is they take lots of computers and they scan all the data across those computers and feed that all back to a single machine. So what they have is multiple machine MapReduce inside of the NoSQL world. What do we have in the SQL world? We have order by limit. We take some data, we sort that data, we provide a limit, we say we like 1 through 10, 50 through 100 in all of these, you know, some type of piece. In the NoSQL world, on the other hand, they have natural data order. Well, what does that mean? That means they write all the data out to disk and then they take it all back in natural data order because, well, of course, you would actually never want the data in any other order than the way that you actually wrote it, right? So that's what they have. They have natural data order. And on top of that, if they need to change something, they have, well, MapReduce. They can go in and take a lot of machines, modify the data, and make it work like that. Poorly. Poorly, very poorly. What about features? What kind of features do we actually see in the NoSQL world? I mean, what are they bringing to the table that we haven't seen so far out there? Well, in the NoSQL world, what they have is generally forward-rolling logs. What they do is they design a lot of their systems such that they have a disk, and they start writing data, and they have a file, and they keep writing data, and then they keep writing data, and then, well, they keep writing data, and they keep writing data because, well, you know, they'd never run out of a single disk. That sort of technology has never actually failed anymore. You know, no one's ever needed to create, say, a vacuum system at all to actually take care of a problem where maybe you might fill up the disk. Because, of course, the data, you know, is never going to overfill an entire disk. That would just never happen. So in the SQL world, they think a lot about forward-rolling logs. Non-transactional. All of these systems, the non-SQL systems, the NoSQL systems, are all non-transactional. And we know that because, well, they just don't believe transaction needs to exist. I mean, why would you actually ever need a transaction? I mean, there's never been a point in time in our world, in the open source world, where anyone's ever actually made fun of a database for not having transactions for any period of time. I mean, that would just be unheard of. Who'd actually think about that? So, NoSQL, fine, non-transactions, never been a problem at all in the history of open source databases. It's always been just fine. They're also schema-free. You don't need to design schema. What you do is you have some data, you push it into the NoSQL solution, and then you push some more data in, you push some more data in, and there's no need to actually be confined to things like schemas or tables or any kind of relational operation whatsoever. It's just not needed because you've got all these machines that you can just say, please find my data. And you just buy, if you need to find data faster, you just buy more machines. Because really, I know where everything is. Please do not touch. And in the end, really the problem gets back to is that SQL kind of sucks. Who wants to learn what is, not that awesome of a language? It's really not that functional. It's not Python. It's not C++. It's not, Ruby. It's not a very good language at all. This was an excellent slide we found. The first slide says, hey, so how do I query the database? The next guy says, well, it's not a database. It's a key value store. Next guy says, hey, it's okay, it's not a database. How do I query it again? And he goes, well, you need to write a MapReduce Erlang function in order to get you data. And then the guy says, did you just tell me to go fuck myself? And the next guy says, well, I believe I did, Bob. Because, this whole ad hoc query thing, who really needs this stuff at all? It's just unneeded. Why do we need SQL? Everybody can write Erlang MapReduce functions daily at their jobs, on demand. Who else would need anything else? And really, at the very end of all of this, really, a lot of this is about what are we actually doing to our planet. SQL, it's not doing much to actually help with global warming at all. With MapReduce systems, we need to buy more and more computers. And 6% of the power on the planet currently today goes to data centers, And obviously, with our global warming needs, we need to buy a lot more computers. Anyway, thank you very much. Let's see, and next up is Mark Atwood, who will actually be explaining us the SQL world, the other side of this equation. There you go, Mark.
Thank you, Brian. So I'm here to talk to you about MySQL and none of this NoSQL stuff. We're all MySQL fans and we all like the relational model. But to start, I'm going to describe what the relational model is. Next slide. A consistent transactional data store with schema guarantees that uses the relational algebra to access normalized tables. We all know it. We all like it. It's used everywhere. Why is it used everywhere? Because it has ubiquitous successor classes and a deep bench of skilled architects, developers, and operations staff, e.g., all of us. There's a problem, though. It's not as fast as we would like it to be. So, if we make a couple of compromises, we write some code, it'll get fast enough. The first thing we do is we do replication, write master, read slave, because, we really didn't like the accessor class that came with our ORM, so we'll write it again, and we didn't need perfect consistency anyway. But, sometimes even then it's not fast enough, so we make a few more compromises, we give up a little bit more, we write some more code, and here's what we get. More replication, lots of read slaves, because we meant to rewrite that accessor class again because we didn't like it the first time. Plus, you really meant to get into MatKit really deeply anyway. But what if it's not fast enough again? Well, there are other things we can do. There's some magic pixie dust, or rather, a horde of magic rabbits we can pour onto it. Memcache, because screw consistency entirely, and we didn't need anything that looked like a transaction. And you really meant to rewrite the entire application anyway. But it's still not fast enough, and now it's too big to fit on your machine. So give up a little bit more, and shard. It's because you meant to buy lots and lots of machines, and you meant to hire lots more operation staff because that's good for the economy. And you needed to rewrite the application, and the developers were never using joins right in the first place anyway. But now, your write masters, they are bottlenecked. Well, we're using MySQL because it's cheap, right? And our sites are making buttloads of money, so we have lots of money to spend on the solution. Who cares about scaling out? Let's scale up. Spend all of that money. Bigger servers, expensive fast RAIDs. Let's start buying those SSDs, faster switches. Just buy more and more bigger computer, and we get rid of the bottleneck, right? But now our bosses are telling us he wants the thing up 24/7. And we added all these machines, they're crashing all the time, the site's going down all the time. Well, what do I do now? I know, DRBD, more RAID, slave promotion, because, we all wanted to learn how to recompile our Linux kernel, load beta drivers, and write lots of really fragile scripts. Now that we've gotten this big and we have our table spread across 1,000 machines, we can't run alter table anymore. It takes days. Well, you only need to write it one more time. You didn't need the schema anyway. So you put all of your data in one column named data, you pack it in a JSON format, and now your developers are happy. So we had to give up a few things. It didn't do the strike through. We gave up the consistency, the transactions, the schema, the guarantees, the relation algebra, the normalization, the tables, but we still do have data access. And, well, the accessor classes are all custom to us, and there's a deep bench of, well, not so experienced architects, developers, and operations staff. That is us. Thank you very much.
So that's the end for tonight of our talks. And at this point, we need to figure out who all we'd like to see go on to tomorrow's quiz show known as the keynote. So let's actually start out with the first person who gave a talk. Backups don't make me money. Sarah, how many people here? Let's hear it up. Some clapping people. Okay. Definitely hear some response. I would put Robin up, but he's actually bailing and getting on an airplane to like see his children or something. Boo, yeah. Next up, we have Jerry doing monitoring. Let's hear. How many people would like to hear Jerry actually do his talk tomorrow? Okay, next on this is Todd with painting data with entrance and MySQL. After that, let's talk about Baron. What is the difference between ExtraDB and others? Okay, and after that, how about Bradley? What is performance models for SSD? On to Jillian, the Gunson rules for database administration. Well, I think we have at least a definite winner there. Next on top of that is Monty, MariaDB, 20 slides, 5 minutes. Next up after that, we have Sherry with the MySQLtuner 2.0. We might as well skip me. That was horrible. And after that, thank you. And after that, we have Mark with his SQL. How about that? Okay. Well, I think we definitely have two clear winners. Well, I'd like to thank you all for coming out tonight and joining the first Ignite MySQL. Next year, remember, you too could be on stage. So I hope to see more of you here next year. Well, thank you very much for your time, and I hope you enjoyed this evening.